In order to really understand what's going on with a graph of the type that we're going to be using, you really need to have an understanding of slope. And slope is really one of the most important ideas in all of mathematics and science. It will come up time and time again, so it's something that's very much worth getting right the first time. And really what slope is you can think of it two ways. If you're looking at the picture of a line, it's just how steep the line is. So the more steep the line is, the greater its slope. On the other hand, if you're thinking about it more in terms of what's actually happening, slope is just a rate. It's how fast one thing is changing versus another thing. And we'll kind of look at both definitions, but let's start with just looking at a picture of a line and determining what slope means. So I'm going to draw our axes. This would be the y-axis, up and down, and the x-axis left to right. And if I have a line on this, let's say a line that looks like that, the slope of that line is really just how steep it is. The more steep it is, the greater the slope. And by steep, you can think of it, if this was a hill, and you always start from the left and go right, how difficult would it be to walk up this hill? The more difficult it is, the greater the slope. So this would be kind of an in-between slope. If we want something with a greater slope, it would be a hill that is more difficult to walk up. So that would be an even greater slope. And then if we wanted to have even more than that, this would be an even larger slope until we get to the very special case where the line's straight up and down, which we're not going to see very often, where we call that an undefined slope. It is perfectly steep. We're not going to get into that too much. So again, the steeper it is, the harder it is to climb the hill going from here to here, the greater the slope. If we have something that is perfectly level, that's not hard to climb this hill at all. It's flat ground. We call this zero slope. So as we start like this, and it's very, very steep, it gets less steep, and the value gets closer to zero until we get perfectly level, where the slope is zero. We can also talk about the case where we're going downhill. Notice this is different than before, because if we start from this side and we walk over this way, imagine yourself walking along the line, we would be going downhill instead of uphill. And so this has a value for slope as well. And the steeper this goes downhill, the greater the slope, except that the slope here would be called negative. So we have three situations. This would be a positive value of slope. It's pointed uphill, and the harder it is to walk up the hill, if you imagine yourself walking along this line, the harder it is to walk up the hill, the greater the slope. So this is positive slope. If it's a flat line, that's zero slope. And if it goes downhill, that's a negative slope. You will have to, I would just recommend memorizing those three cases. After you see it enough, it'll sort of become second nature and you won't even have to worry about it. But for now, be aware of this. All right, now let's talk about how to calculate the slope, how to actually get a number for it. And so let's take a line that looks like this. And in order to calculate the slope, we have to have numbers. So I'll make some scale. And note that this is not perfectly accurate. I'm just making this up as I go, essentially. But in order to calculate the slope of the line, you need 2 points on it. And they can be any 2 points you want. So like maybe I want to take right here and right here. And now I want to find the slope of that line. And when you do this, you can think of slope as this. Slope is that right there. Now that may seem like gibberish to you. Let's break this down, unpack it, kind of look at each part. This triangle is actually the Greek letter delta, and we use delta to mean the change in something. So delta y means the change in y. Let me just write that over here. So that means the change in y, how much did y change? And then likewise, delta x just means the change in x. And sort of implicit in this, it's meant in there, but it's not specifically said, is that this is the change in y and the change in x as we go left to right, starting over here at the origin and moving this way, or if it's negative, starting most to the left and going over. So now, we know that slope is just how much the y value changed and how much the x value changed. Well, let's put some numbers to this and let's actually look at it. So this point right here, I'll call it 2, 2. We'll say that's where that is. Again, this is not perfectly accurate. So, and we'll call this point 4, and that's just over 4. We'll call it 4.5. And now I want to find how much did my x change and how much did my y change going from left to right. So let's take a look at it. My x started out at 2, and then as I went over to here, my x changed to 4. So the x value went from there to there. So how much did it change by? Well, it changed by 2. The way I can find this is by taking whatever the final x value was minus the initial x value. So 4 minus 2 is 2, or you can just count that it moved 2 places. So my change in x, and be careful of where these go, my change in x here is just 2. Now I can do the same thing for the change in y. My first y value was 2. My second y value was 4.5. So I need to know how much it changed going from here to there. So it changed by 2.5. 1, 2, and then that half. And again, I can find that by taking this final one minus the initial one. So my change in y would be 2.5. And so now, when it comes down to it, all I have to do to calculate the slope of that is to do 2.5 divided by 2, and it is 1.25. You have to forgive me, I didn't trust my math this early in the morning. The slope is 1.25. So we've numerically found, that is using numbers, we've found the slope of that line. And this works in any case. All you have to do is take 2 points, starting with the left one. How much did the x change? That goes on the bottom. How much did the y change? That goes on top. And that's how you calculate the slope of the line.